All right, so this is just summation practice, and I'm doing one arithmetic and I'm doing one geometric. So for arithmetic, this is my sigma, my lower bound is 2, my upper bound is 5, and my pattern that I'm going with for the sequence is n plus 7. I could write this out, it's just 4 terms, it's not a big deal, but we can also split this up. So I can split this up, keep the same lower, keep the same upper, the n becomes this first argument, and then I split it. So what's the next argument? Just the 7. The n comes down, becomes an argument, the plus goes in between them, and the 7 becomes my second argument. Now, what's really cool is that with this one, this is just 7 4 times, because I have it for n is 2, n is 3, n is 4, n is 5. Okay, so I have it 4 times, so this is just 7 times 4. Okay, and then on this one, I'm going to have just 2 plus 3 plus 4 plus 5. If it's nice and small, yes, you can still do it. But if it was larger, we know what the first term will be. We know the first term will be a sub 1 is going to be 2. We know that the the last term is going to be 5. If you know the first and the last term, and we know the number of terms, I can't use n in this case because it's already been used, but the number of terms in this case would be 4. I can use 8-4's formula and say, hey, I'm going to have 4 terms. I'm going to be dividing that by 2. My first term is 2. My last term is 5. And now I'm going to have 2 times 7. So this whole summation turns into 2 times 7. This whole summation turns into 7 times 4. So if you multiply those out, you get 14 and 28, which gives you 30, 42 as your summation. Okay, so this is using the shortcut. Yes, you could add those up. But if they were larger numbers, as long as you know the first and the last and the number of total terms that you're using, you can use your formula from 8-4. For geometric, we can also use a formula from 8-5. Sometimes you're going to see series like this, where it starts with 0. Computers don't like starting with 0. We like starting with 1. So this is how your book has instructed you to write your formulas, your summations. You start at 1, so by increasing this by 1, the upper bound also has to increase by 1. But look what the exponents are doing. We have to make this 1 think it's a 0. So 1 minus 1 goes back to a 0. 5 minus a 1 goes back to 4. We have to make it think it's actually in the original format. So just watch that. I would take both, but just watch for computer programming purposes. N equals 1 is a much more uniform and consistent thing. Most formulas and patterns will be based off of the 1 and not the 0, because zeros can get you in trouble. All right, so I'm going to work on this one since this is what our book is going for. First off, I see a coefficient. I'm going to pull it out in the front. I don't need it where it is inside. It's just cluttering things up. Okay? So you could leave it there still. It is useful information. But if you're going to do this more by hand and want to simplify stuff later in your calculator, which I'll show you how to do it in your calculator and then go backwards with the formula, get more stuff out than you can. Again, this is 1/4 to the n, but then I can divide by 1/4. This is the same as saying 32, n equals 1, 5. 1/4 is to the n, divided by 1/4. But if you divide by 1/4, because that's what that -1 says, it says dividing by 1/4, I'm actually multiplying by 4. So I can pull out a 4. What's 4 times 32? 4 times 32. My brain's not working. Okay, 128. So 128 is now my new coefficient, and I just have 1/4 to the n. We're going to see later in 8-7, I think it's 8-7, that if this ratio is less than 1, this will converge. So just an FYI. Yay! That's why this formula works, is because it does converge. We know what the summation will be. So we can now put this into our calculators. I've already gone over how to... no, I didn't. Maybe I didn't. So if you have a nice new calculator, there is a shortcut, alpha window, and click number 2. If you want to do the long way, you can hit math and then go down to 0, and that will also bring up your summation. I am still in the normal. I'm still in classic. Okay, back to the new stuff. Yes, thank you. Okay, so in the new math print, if you go to summation, it has all the blanks for you. Type it all in, see what you're good. You're golden. Awesome. I want to go to classic and show you what an older model looks like. So go to math, go down to 0. So I'm clicking on the math menu. I'm clicking on 0. And now I have a summation. So in this summation, I'm going to first put my argument. So my argument in this case is 1/4 to the n power. So in parentheses, I'm going to do 2. I'm going to have my 1/4 by itself. I'm going to go to the x power by itself. So notice I have 2 sets of parentheses, all putting it in there. Commas above your 7. So after your argument, then you put x, because that's the variable that we're using. Then put another comma, and then put your lower bound, and then comma your upper, and close off your parentheses. So I'm going from 1, comma to 5, close off the parentheses. This is my summation. Okay, so yes, it's a fraction. I want that then multiplied by 128. So I'm going to do times 128. And this is my final answer of 42.625. Math frac will also give me the fraction of 341/8 because 6.25, I think is like 5/8. Yeah. Or you could do 42 and 5/8. Okay, so that's using your calculator. If you wanted to use the formula, we could have actually done it straight from here. This, let me use purple. This is your first term. Okay, so G for geometric because we're not that fancy. This is my ratio, or the scale factor common ratio that we want. And I have 5 minus 1. I know I'm going to need, well, this should be 5 terms because I'm going to 5 terms. Because I'm going 1, 2, 3, 4, 5. So I have 5 terms. So my n is 5. So in your formula, and yes, you're going to have to know this. So the 5th summation in this series, I'm going to take my first term of 32. I'm going to be doing 1 minus my common ratio of the 4th. And this is to the nth power, which will be 5. All over 1 minus my 1/4. And you're going to do this a lot in your homework, so you better memorize it. So I have 1/4 to the 5th power. I would do the whole numerator in one line and then divide by the denominator. So I'm going to do 32 minus 1 minus, and you can do 0.25 if you want for your fraction, just to help clear up some decimals, to the 5th power. And I notice I'm still in classic mode. Hit enter, and then I'm going to divide by, you know what this is. Okay, so I'm going to divide by 3/4. And I should end up with 41.3463 if I did math frac. Hey, look, I end up with not the same number. Why did I not end up with the same number? Why is it over 68? What did I do? Interesting. Let's go back to math print and see if it's something I did there. Because I did the formula correct. I did the formula correctly. Okay, so my first term is 32, 1 minus, and I'm going to do 1/4. I'll do parentheses, and then I want it up, and I want to go to the 5th power just on that 1/4. Enter. That's my numerator. Divide by, that is 3/4, so divide by 3/4. There we go. So I don't know what I did with the classic method, but watch your parentheses, because obviously that's an issue. So that's the formula. You're going to use this a lot in your homework. So just an FYI, make sure this to the n power is only on the r. It's not on this whole parentheses thing. Alrighty.